Very good morning to all. I am Dr. R. Udayakumar, Professor and Dean, Department of Computer Science Engineering and Information Technology of Kalinga University, Naya Raipur, India. Again, we are talking about computer organization and architecture. In that, we are going to see about the memory transfer. What is memory transfer? The transfer of information from a memory unit to the user end is called as read operations. So, the transfer of new information to be stored in the memory is called as the write operation. A memory word is designated by the letter M. We must specify the address of the memory word while writing the memory transfer operations. The address register is designated by AR and the DR is designated as the data register. Thus, a read operation can be stated as read DR transfer the data from M, that is with AR. The read statement causes a transfer of information into the data register from the memory word M selected by the address register AR, and the corresponding write operations can be stated as write MAR from R1. The write statement causes a transfer of information from register R1 into the memory of word M selected by the address register AR. How the processor organization is done. Now we see a central processing unit is also called as a processor. Central processor or microprocessor. It carries out all the important functions of computer. It receives instruction from both the hardware and active software and produce output. A main memory which stores both data and instruction. An arithmetic and logic unit ALU capable of operating on binary data. A control unit which interprets the instruction in memory and causes them to be executed. Input or output equipment operand by the control unit. It stores all the important programs like operating system and application softwares. CPU also helps input and output devices to communicate with each other. Then the role of register in the organization. Let us see the role of register used in the computer organization and architecture. When we are using multiple general purpose registers instead of a single accumulator register in the CPU organization, then this type of organization is known as the general register based CPU organization. In this type of organization, computer uses two or three addresses field in their instruction format. General register CPU organization are two types. One is general memory reference architecture. Next one is general register reference architecture. Now let us see the functions of register memory reference architecture. In this organization, source is always required a register. Source 2 can be present either in register or in memory. Here, to address instruction format is compatible instruction format. Number 2, register reference architecture. In this organization, ALU, arithmetic and logic unit operations, are performed only on a registered data. So, operands are required in the register. After manipulation, results is also placed in register. Here, 3 address instruction format is the compatible instruction format. Next, we see about the stack organization. Stack is a storage structure that stores information in such a way that the last item stored is the first item received. It is based on the principle of LIFO, last in, first out. Stack operations. The 2 operations of the stacks are push and the pop. Push instructs an item on the top of the stack. Pop deletes an item from the top of the stack. Addressing modes. The term addressing modes refers to a way in which operand of the instruction is specified. The addressing mode specifies a rule for interpreting or modifying the address field of the instruction before the operand is actually executed. The way any operand is selected during the program execution is dependent on the addressing mode of the instruction. The purpose of using addressing mode is classified as to give the programming versatility to the user to reduce the number of bits in addressing field of instruction. Here we see the addressing modes. There are 10 types of addressing modes. They are immediate mode, register mode, register indirect mode, auto increment or decrement mode, direct addressing mode, indirect addressing mode, displacement addressing mode, relative addressing mode, base register addressing mode, stack addressing mode.